Hello everyone, good morning. Today we're going to finish 7.1 and we will be wrapping up day 3 on finding rational solutions of polynomial equations. And today's focus will be able to solving real-world problems using the rational zero theorem, or otherwise known as the PQ theorem. So let's take a look at the first problem here. An engineer is designing a storage compartment in a spacecraft. The compartment must be 2 meters longer than the width, and its depth must be 1 meter less than its width. The volume of the compartment must be 8 cubic meters. So as you can see, this is a word problem that does not have any picture or graph to represent. So we first want to draw a picture to represent it. So let's go ahead and try to draw a rectangular box, and let's label that length, width, and height because it's describing those dimensions. So the compartment must have must be 2 meters longer than the width. So we're going to let the width be x, and then therefore the length will be x plus 2, since that is 2 meters longer than the width, and the depth, which is the height, must be 1 meter less than the width, so that will be x minus 1. So those are the dimensions, and as you recall, we have the formula volume for a 3-dimensional rectangular prism is length times width times height. And we are given that the volume of this compartment must be 8. So we're going to let it be 8. And then we will just substitute the units that we found. The length is x plus 2, the width is x, and the height is x minus 1. So we're going to simplify the problem by just distributing the x through to both. So we will have x squared plus 2x, and then we still have the x minus 1 in the back. And then we're left with a 2 by 2, so we're going to FOIL the answer on the right hand side, the factors. So we're going to have x cubed minus x squared plus 2x squared minus 2x. Combining the like terms that we have on the right hand side, and we're also going to zero it out. So we're going to subtract 8. So we're going to do two things at one time. Zeroing it out, we have x cubed. The 2x squares terms will combine into a plus x squared, and then we have a minus 2x minus 8. At this point, now that we have the the equation equal to 0, we're going to use the P and Q method, which is the rational zero theorem. So we're going to start by finding the we're going to find the list of possible zeros. So we're going to use P over Q. And we're going to list the factors of 8, which is plus or minus 1, and 8, and 2, and 4. Divided by the coefficient, leading coefficient is 1, so that will be plus or minus 1. And when you divide everything by 1, you will have the list of possible zeros, which is highlighted right here. So this will be the list of possible zeros. There's 8 factors. So that's the answer for part B. So let's go ahead and continue with part C. Using synthetic division to find the roots of the polynomial equation. So we're going to test the possible zeros. And let's go ahead and start by listing the coefficients of the polynomial function, which is right here. 1, 1, negative 2, and negative 8. And we're going to test, let's go ahead and test 2. Bring down the 1, multiply, we have 2. 1 plus 2 is 3. 3 times 2 is 6. Combining, we will have 4. 4 times 2 is 8, and we have a 0. And we're going to rewrite the rest by reducing the degree by 1. So we have x squared plus 3x plus 4. And setting that equal to 0, we're going to attempt to factor. And I don't think this is possible to factor. So therefore, we are not going to be able to get any zeros, rational zeros out of this one. So if you use quadratic formula, you're going to end up with the radicals and maybe imaginary. So these factors, this right here will give me complex roots. And so the only real zero is x equals 2. So therefore, the width is actually 2 meters. So what are the dimensions? Length, width, and height. So originally we had let the width be x. So the width is x, the length is x plus 2, and the height is x minus 1. So that is the original. And now that we have found x, we can actually substitute in, and we got the length is 2 plus 2, which is 4 meters. And then the width is 2 meters. And the height is 2 minus 1, which is 1 meter. And if you multiply 4 times 2 times 1, we will get 8 cubic meters, which meets the requirement for the volume. So that answers our question. The dimensions are 4 by 2 by 1. And that is the end of the problem. And now it is time for you to try this problem. So go ahead and pause the video and try it exactly the same way that we just approached it earlier before you move on to see the answer. Well, hopefully you've had a chance to try this problem, and let's go ahead and take a look at the problem. A box company is designing a new rectangular gift container. The marketing department has designed a box with a width of 2 inches shorter than the length. So again, it is describing a box. So we're going to start by drawing the box again and label it length, width, and height. And let's go ahead and use the information to label the box. It says the width is 2 inches shorter than the length. So the width is going to be x minus 2, and the length is going to be x. So we can let x be the length. And then the height is 3 inches taller than the length. So it's going to be x plus 3 for the height. Once again, the volume we want is 56. So volume equals length times width times height again. And we're going to let the volume equals 56. And then substitute the length, which is x, times the width is x minus 2, times the height is x plus 3. Again, we're going to distribute the x through. So we have x squared minus 2x. And we will go ahead and FOIL that with the answer of x plus 3, the other factor, and we still have equal to 56. So FOILing this, we'll have x cubed minus, actually plus 3x squared minus 2x squared and minus 6x. And then we're going to zero the other side out by subtracting 56. So we're going to just bring the 56 over and set it equal to 0. So we have 0 equals x cubed. These two x squares will combine to be a plus x squared minus 6x minus 56. And that is the polynomial equation to represent the situation. It says list all of the possible zeros. So again, we're going to start with the PQ method. Q is equal to 1. So P over Q is going to be plus or minus 1 times 56, 2 and 28. And then I believe there is 7 and 8. So that's the complete list of factors for 56. And then for Q, which is just 1, and it's just going to be plus or minus 1. So if we divide everything by 1, P over Q, that's just going to leave the top as the list of possible zeros. So there they are. We have the possible zeros right here. Okay, this list, which is 2, 4, 6, 8, 10, 12 possible zeros. And now we're going to use the synthetic division again and list the coefficients. And there they are. And we're going to try one of the factors. So let's try 4, everybody. Let's try 4. 1 times 4 is 4. Combining 1 plus 4 is 5. 5 times 4 is 20. Adding the two together, we will have a 14 times 4, which is 56. That gives us a 0. Yes, so we have a 0. So let's reduce this to x squared plus 5x plus 14 as the remainder. And again, I can't think of a way to factor this, so it's not factorable. So when you set this equal to 0, you're only going to have complex answers, complex roots. So therefore, the only real root rational number is going to be 4. So we have x is actually equal to 4. In this case would be inches, talking about inches. So we are letting the length be x. So length, width. So what are the dimensions? Length, width, and height. So the length is actually x, which is 4 inches. And then the width is going to be x minus 2. So that's going to be x minus 2, which is 4 minus 2. That is 2 inches. And then the height is x plus 3. So x plus 3. That's going to be 2 plus 3, which is actually 4 plus 3, which is 7. And if you multiply 4 times 2 times 7, you should get 56 cubic inches. And that is how we check those dimensions are actually correct. So the dimension is 4 by 2 by 7. And that is the end of this problem. Let's take a look at example 2. A jewelry box is designed such that the length is twice the width and the depth is 2 inches less than the width. And the volume of the box is 64. So let's go ahead again to draw a picture to represent, because a picture is worth 1,000 words. So it's a similar problem than the one that we just, the two problems that we just did, length, width, and height. So the length is twice its width. So if we let the width be x, then the length is going to be 2x because it's twice. And the depth is 2 inches less than its width. So it's going to be x minus 2 for the depth or the height. So the volume is given 64. So again, we start with volume equals length times width times height. And by now, you should be very familiar with this process because you've already seen us do two problems together. So you should be able to do this by yourself. So again, the length is actually 2x. The width is x. And the height is x minus 2. So we have an easy monomial times monomial, which is 2x squared. And then we got x minus 2. We're going to distribute the 2x squared through. So we have 2x to the third minus 4x squared. And then we're actually going to bring the 64 to the other side, right? So let's go ahead and minus 64. So we have 0. And let's go ahead and I can see that there is a 2 that is in common. So remember, we always should take out GCF. And this is an equation that is equal to 0. So when I divide everything by 0 on the left, I still have 0. And I can reduce that to x cubed minus 2x squared minus 32, which makes the problem smaller now. So let's go ahead and use the PQ method again by listing all of the zeros, the possible zeros. So here we are, P over Q, which is 32 is going to be kind of long, right, for the list of factors possible. So let's go ahead and list that. That's going to be 1 and 32, 2 and 16, 4 and 8, and I think that's it. Then over plus or minus, again, the coefficient for Q is 1. So if you take everything on top, divided by 1, you're going to get this list of possible zeros. So here is your PZ, possible zeros. And that answers part B. And then part C, we're going to use synthetic division again. So we're going to list the coefficients, 1, negative 2. We're missing an x term. So notice we're missing an x term. So we're going to need to enter 0 for the coefficient for x term. And then we have negative 32. So that's the difference here. And let's go ahead and test out 4. And 1 times 4 is 4. And combining, we have 2. 2 times 4 is 8. Combining, we have 8 times 4, which is 32. And that gives us a 0. Yay! So this is going to be reduced to x squared plus 2x plus 8. And again, I cannot see that this can be factored. So we're not going to be able to get any real roots out of there. So it's going to be x equals 4 is the only rational number. So we have x equals 4. And I believe this is inches again. So x equals 4 inches. And so what are the dimensions? Length, width, and height. So the dimensions are length is 2x, width is x, and the height is x minus 2, right? Let me just double check. So 2x, x, and x minus 2, there you are. And so the length is actually 2 times 4, which is 8 inches. And the width is 4 inches. And the height is 4 minus 2, which is 2 inches. And if you multiply that together, 8 times 4 times 2, that is actually 64 cubic inches. So that is how we know that the dimension is 8 by 4 by 2 inches. And that is the end of the problem. And that is also the end of the day, the lesson for day 3. So go ahead and get started with your assignment for today. Have a nice day. See you next time. Bye.